All right, guys, continuing to work on equations here. It says equivalent. Remember, the word equivalent means equal. So equations that are the same, that are equal. Even the number one on the warm-up, there's a couple different equations you could have wrote for that. That means the same thing. So the first one, just evaluate if n is 5. Okay, so if n is 5, that means the top here is 25. 25 minus 9 is 16. Denominator would be 4 minus 3 is 1. 2 times 1 is 2, so your answer would be 8. And it does say equivalent expressions, so if I would plug that into the one on the right, I would get the same thing as well. Most people choose to just plug it in for the one on the left. Simplified equation. Okay, how would that change if I put 49 in there? Well, 49 minus 9 is 40. Bottom's still 2, so 40 divided by 2? 20. Anybody got the third one? 80. And the last one? Okay, let's do it. Negative 1 squared is 1. 1, no, it's squared, so it's positive 1. 1 minus 9, negative 8. So negative 8 divided by 2 is negative 4. All right, question number 1. Write as many equations as possible that could represent the relationship between the two ages of kids in a family. Be prepared to explain what they mean. The youngest child is 7 years younger than the oldest, who is 18. So one equation would be 18 minus 7 equals the age of this child. So I could put A, or I could just answer it. 18 minus 7 is 11. Okay, other equations that I could write that are true for those three numbers.
11 plus 7 equals...
Yeah, I could say the two ages of them added together is 18. Anybody else?
18 minus 11 equals 7.
18 minus 11 equals 7. 7 plus 11 equals 18. And if I didn't want to do the subtraction, I could just use A for the age of the youngest child. And then you could write all those other equations as well. So notice there's a lot of them that are saying the same thing. Okay, how about the second one? Middle child is 5 years older than the youngest. And the middle child is 5 years older than the youngest. So if I subtract 5 from the middle child, I'll get the youngest. So Y represents youngest here, M represents middle child. If I added 5 years to the youngest child, I will get the middle child's age. If I take the middle child minus the youngest, I'll get 5 years old. So again, all the same equation, same letters, same variables, same numbers, all mean the same. Okay, Tyler thinks he could write this equation. From what we wrote in B. It says that Tyler is correct, but why? How is that similar to one of the equations that we wrote? Specifically this one. Doubling it. Okay, you're doubling everything. Okay, so if you do that, if you take an equation times 2, you got to do it to everything in the equation. Okay, it's similar as if you have a fraction. I'd have to take the top and the bottom times 2. Or the top and the bottom times 3. Or the top and the bottom times 4. I can't just do 1. If you want it to be equal, you gotta multiply everything times 2. So why is Tyler right? We took the entire equation times 2. Okay, so I'm gonna have you look at number 3 on top of the next page, and it says, are any of those equivalent? Are any of those the same? And I'd like you to just peek at it quick, and then we'll chat about it. All right, anybody got one? What do you think?
1 and 3.
1 and 3? 1, 2, and 3.
Aren't they all?
Well, 2 and 4 go together, and 1 and 3 go together.
We're
Okay,
finding which ones are
How does 1 and 3 go together?
They're just tripling it.
Yeah, they're tripled. All right, so those are equivalent. How about these?
Times 9.
Taking this one times 9 to get to this one. Okay, so those are equivalent as well. Now give me a letter that makes this one true. 3. So let's try A equals 3 for all of them. Does it make it true here? Here?
Yeah. Yeah. What?
Oh, yeah.
Here?
Yeah.
Here?
Yeah.
Yeah, so you're on the right track that all of them are equivalent. Okay, to get from the first to the second, I subtracted 6 from both sides. So I did it to both sides of the equation. 6 minus 6 disappears here. 15 minus 6 is 9. To get from this one to this one, you said was divided by 9 or times 9 the other way. That's fine. All right, go to 6.3. I'm going to skip the are you ready there. It says Noah's buying a pair of jeans and using a coupon for 10% off. Total price is $56.70, which includes tax. Gives you the equation. What does the solution to the equation mean? So what does x actually mean in this problem? What is x in this problem?
Your total, like, before tax.
Yeah. Otherwise called the original price. Total before tax. And you can even say what it's for. You can be more specific. It does tell us it's for a pair of jeans. It says, how can you verify that 70 is not a solution, but 60 is? How can we check it? Plug it in. Okay, if you put 70 in here for x, it will not equal 56.7. So 70 minus 7, 63 plus 2 is going to be 65.70. So obviously that's not equal. How do you prove 60 is? You do the same thing and you get 56.7 on both sides. Plug it into the equation. Okay, solving algebraically. Plug it in. Try it. Next page. Here are some equations that are related to our original one. For each equation, determine what the move was and how the equation could be interpreted. then check 60 if it works in your equation. All right, so what did I do? So here's my equation. What did I do to the first one to get that? You took it times 100. Multiplied everything times 100. Do you get the same solution? Well, let's take 100 times 60. If you got a calculator handy, that'll help. And let's make sure we get 5670. 100 times 60 is 6,000 minus 600 plus 270. Do I get 5670? Yes? So same solution. We're just write yes there. Okay, B, they did it for us. They said they subtracted 270 from both sides. Okay, now what is this actually showing? I forgot what the 270 was. Tax? 54 is price before tax. Do you get the same solution? Well, let's try it. 60 minus a tenth of 60. Do you get 54? That'd be 60 minus a tenth of 60 is 6. Is 60 minus 6, 54? Yes, so again, same solution. Okay, how about the next one? What did we do? How'd they get 0.9? Nope. Nope.
Oh. They took away that, line one.
Yeah, they combined like terms. They combined 1x minus 0.1x. 1 minus 0.1 is 0.9. Okay, now what does that mean in interpretation? Well, 100% minus 10% off, you're paying 90% of the original price. That's where the 0.9 comes from. Same solution. Well, let's check it. 0.9 times 60 plus 270. 0.9 times 60 is 54. Plus 270 is 5670. So again, same solution. All right, same directions for 3. What did we do?
Got rid of the 270.
How?
It's already added in.
So subtracted 270 from both sides?
Yep.
No,
Well, don't you gotta?
you only subtracted 270 here.
But don't you need to do it to both sides?
Oh, let's see, Caleb. Let's see if 60 works in this equation. 60 minus 6. Do I get the same thing on both sides?
No.
No. So you just found something you can't do. You can't just get rid of 270 on one side. As Caleb was mentioning, he was already noticing that's no good. What you do to one side of the equation, you got to do the other. You can't just say, oh, I'll just get rid of that 270. Just cross it out like it's not even there. Okay, it doesn't work. Equation E, what'd they do there? Yeah, so the left side, they subtracted it. Right side, they added it. That's even worse of a no-no. Okay, because now you're gonna get 54 on the left side and 5960 on the right. Of course, that doesn't work. Okay, what are they showing on the next step?
Everything in the parentheses is taking times 2.
Yeah, so they're taking the left side times 2. What are they doing to the right side? So you think that one's gonna work? Left side times 2. So you're gonna get 60 minus 654, 5670. So you get 5670 on the left side, but then it's times 2, which obviously doesn't equal 5670 on the right. Says which of the 6 equations are equivalent to the original equation? First three. A, B, C. How do you know? Well, we plugged in 60 and got the answers that we should. Both sides were equivalent. Okay, so be careful. Don't assume that every equation is created equal. You just found 3 that they made mistakes on. Okay, equivalent expressions. The one little saying I'm sure you've heard before, what you do to one side, you gotta do the other. Can't just pick and choose. Gotta keep the equations equal. Think of it as a balance. Okay, what you do to one side of the equation, you gotta do to the other, or it's not gonna stay balanced. If I take this side times 2, I gotta take this side times 2. If I subtract on the left, I gotta subtract on the right. Okay, so keep that in mind. Equivalent equations. If I divide one thing by 2, I gotta divide everything by 2, and so on. Okay, you're gonna get a lot of practice of which ones are equivalent here, starting on the homework. First equation there, first question, multiple choice. 2, all, circle word all. 3, multiple choice. 4, all. More than one. Okay, 5 through 9 is going to be a review. Most of them are multiple choice. 7 and 8, again, select all, more than one answer. And not really any graphing or anything to do here. And plenty of time to get rolling on that. So 2.6 due tomorrow.